Hello everyone, welcome to part 17 in my series on DLL injection into all processes. And today I decided to record a short follow-up, and basically I need to fix a couple bugs in the driver project itself. And also I wanted to show how you can test it on older operating systems. In this case we will be testing it on Windows 7. Because remember, in our development process, where we're basically testing the project on Windows 10 exclusively, since we were developing it on that operating system, well, it would be also prudent to test it on older operating systems, like, for instance, Windows 7. And also, I will show you how you can do crash dump analysis and just show you how you can use additional tools which I originally asked you to install. Okay, so without any further ado, let's go back to our development environment and let's start IDE and load our project. If you watched all previous 16 tutorials, you'll know that we were working with inject all solution. And in most cases, at the most, it is actually written and ready. There's just one bug that definitely stands out. If you look at our FAKE.DLL, and if we go into driver DLL main, now every time we log something, that log actually calls log to file formatted. And what that function does, it basically writes it into a file, into a text file. Well, let's look at this macro once again. As you can see, it automatically adds a new line at the end. Well, older version of Windows, to be able to see actually new lines in a text file, it required this kind of a sequence to be there. So to make sure that we can read our log file a little bit better, let's just put, full new line over here. And that's basically what we need to do. Now, this is only in a DLL types. We don't need to do this for debug view output. And yeah, so that's what we needed to do. At this point, let's rebuild all. And again, we have to do all of this. Technically, we can do batch build, but at this point, I'm just going to just do it manually so that you can actually see the steps involved. And here you go, I'm doing release and 64-bit. Then we are going to switch to 32-bit. Again, build, rebuild solution. Technically, all of them should build without any issues. And then we go into debug and rebuild, debug build for x32, for x86 for 32-bit. Okay, and we go back to x64. Okay, now what I didn't show you guys is this tool, this PE internals tool. Let me show you why I needed it in the first place. Now, if you remember sometime in the past when we were working with our DLL, let's just go into DLL main, I told you that this is important for us to include this load config file .c that will include control flow guard parameters, not just parameters, but all kinds of functions and all kinds of stuff that is used for control flow guard. Well, I didn't show you how you can test it. Now, if you remember, the debug build did not have control flow guard structures and all kinds of internals included into it. And how can you tell? Well, the easiest way is to get the executable, let's say FAKE.DLL debug build, again without any control flow guard structures. If we drag it into PE internals, and this basically shows us the structure of the PE file as a binary hex dump, which is very easy. And on the left, it actually gives you a structural view. So if we go into section RData, and there's this image load config directory, and then the bitness. And then we can see these, well, I guess members. And this one, CF functions, is control guard functions. As you can tell here, there is nothing here. It means control flow guard is not really enabled for the debug build. And if we go into release and do the same thing, drag FAKE.DLL into the PE internals, and again go to section R data, and you can see there's way more here. Image load config. As you see now, we have actual functions. We have 5 of them, and we have a table defined at this location. So this basically how you can tell if the control flow guard is enabled in a PE file. Now I'm sure there are other ways to do this, so I'm obviously not saying that's the only way, but this is how I was using, and this tool is really kind of handy for this. Okay, well, next thing, like I told you, I wanted to test our file, our driver, on a Windows 7. So if we look here, properties for the computer, you can tell that this is 64-bit operating system, and this is Windows 7 Professional right here. So let's try our driver on this operating system. Now, as you can see over here, I already pre-downloaded all the tools that we needed. I set up Windows error reporting to report all the crash dumps into this folder. And let's make sure that there is nothing in here. It's a C crash dumps. As you can see, it's empty. And if you start up driver loader, unloader, as you can see, I set up test signing already. And also at the bottom right corner, we can tell that. I also got debug view, and I got process hacker that will show us what's running on the system. And I also created a folder, inject all, and that's where we will put our driver. So let's remove it for now. Okay, so let's prep it up, and let's run our tool as administrator. Again, everything has to run as administrator, obviously, since we're dealing with the driver. And over here we have a debug view. Now the thing about debug view, I had to use an old version, 4.81, because for some reason the latest version of debug view was refusing to run on Windows 7 that I had in this VM. I don't know why, but I had to find an old version, and that ran fine. We need to enable verbose kernel output, which for some reason it didn't want to remember every time I started. And now we need to go back to our development system, and we need to copy everything. So first, let's copy the DLL, and let's do FAKE.DLL. We have to copy both of them, if you remember. So I'm going to copy it on the desktop, and let's see, then we go into C, Windows, System 32, and let's drag it here. Now I already have it in here because I tested it already. And let's see, well, we have a little bit of an issue here. As you can see, it's already in use, and I apologize for that. So what I should have done, I should have rebooted the system. So let me do this real quick, and I'll get back to you shortly. Okay, here we go. And by the way, the reason why FAKE.DLL refused to be copied into System 32 folder is because it was loaded into some other process when I was testing it earlier. So let's see, and as you can tell, it worked just fine. So then we need to do the same with 32-bit version. And let's take that from over here, FAKE.DLL. Now guys, again, I'm just showing you this so meticulously so that you can see that, it's a very manual process, so you have to kind of do it very carefully, because if you put the wrong DLL into the wrong folder, it's not going to work well for you. It's very easy to just, BSOD or cause the blue screen on the system, and then basically you'll have to start over. And let's see here, we need to get a 64-bit version of our driver. and we need to copy it right here. Okay, so let's run our driver loader unloader. Let's make sure that the driver is unregistered. Okay, and it is. And then let's run our debug view, and again we have to enable this thing, which it for some reason doesn't want to remember. Okay, so at this point we have our full version of the driver, and let's try to register and start the driver. And boom, we have a little bit of a problem here. Now, if you probably know what blue screen of death is, you are looking at it right now. So what's happening is that right here you have what is known as a stop code or a BugCheck code, and this is 7E. And these are parameters that the BugCheck actually fired. This one is the name of the driver, and well, it rebooted so quickly that I wasn't able to show it to you. But what I did, I actually made a screenshot, so we can actually work with it. So if you look again right here, this is the BugCheck code, and these are parameters that we have going on. Now this is the name of the driver, which is obviously our driver, and the rest of it is not very interesting. So let's boot back up. Now what happens here in this case, well, obviously Windows is showing you that, okay, here's a BugCheck, here's the code. And the first thing first, what I would do, I would load up a web, let's see, what's it called, a web browser. Then I would say BugCheck. And by the way, BugCheck is the official Microsoft name for blue screen of death, so they obviously don't call that. And then we specify the error code, and then we run it. And well, I wouldn't go into like this answer, but I will check the official Microsoft MSDN page. And this basically says that this is system thread exception not handled, and it's the same as BugCheck 7E. It's just a little bit, extended version. So let's go here. And then we need the second parameter. And if you look here, the second parameter is 8 and then 3 at the end. Obviously, we're ignoring all these Fs. It's just, D word extended into 64 bits. And we have status breakpoint, indicates a breakpoint or assertion that was not caused by that was not caught by a debugger. Well, this is kind of interesting. So if we go back to our development environment, and you could tell right away that the crash basically happened in the driver entry. So it's like literally, it just immediately, as soon as I started it, it crashed. Well, it could be here, it could be here. There's two possibilities. Well, unfortunately, it crashed in a sense that we did not have any output, because we did have debug view running, so that didn't help. So the next step would be to just comment this part out completely and just run without it. Just do the one output, and also just kind of like comment this out and just do driver unload and see if that works. I will save you some time. I tried it, and it also resulted in exact same bug check like this one. So that was kind of interesting. So I started looking further into it, and it was just I was getting deeper and deeper, and I couldn't figure it out. So that is why the next step that you can do is actually use a crash dump that Windows generates. So if you go into C, Windows, and search for memory dump, this thing here is a memory dump during the crash. So let me cut and paste here. Okay, so at this point we need to analyze it. We cannot analyze it here on this test environment. So let me copy it onto my... Okay, well, let's see, the VMware is not cooperating. Let me try again. Cannot get attributes on file. Now what the heck? Okay guys, I'm gonna stop this and I'm going to coax the virtual machine to actually, copy this file, and then I'll get back to you. Okay guys, sorry for this. Basically, in between of fixing your own bugs, you have to deal with bugs in someone else's software, like in this case VMware. So I was able to copy the memory dump file from our operating system that failed into our debugging environment, and here it is. So the next thing to do is to actually put it into the folder where we have a symbol file for our driver that failed. Now make sure that you didn't build it again, just kind of like stick with the same version as you put on that test system. And the next thing to do is actually to drag it into WinDbg. Let's see, and WinDbg does not cooperate. How great. So let's close it and start over. Now WinDbg is my least favorite tool. I know people use it, and but oh my goodness, it's like it lives on a planet of its own. Now if you need to get WinDbg, unfortunately it's not really easy. So WinDbg download and go to official Microsoft site. Don't take it from anywhere else. And this page basically explains what you need to do. You need to download Windows 10 SDK. It will come as a huge installer. Make sure to uncheck everything except debugging tools for Windows. Run it. It will download about 200 megabytes of something. Yeah, I know, a lot of waste. And then at the end, it will give you a WinDbg in the start menu. So you can go here and type in WinDbg, and it will give you, this thing that you can run. And then you can create a shortcut like I did here. Okay, so to run it, evidently you can't drag a file into it. You have to start it like so, and then drag the memory dump into it. And then, let me maximize it. Okay, so it will give you this preamble, and then basically what you need to do is just do bang analyze space v space dash v. We can just click on it, and it will do its thing and basically give you the crash dump analysis. Now this part, basically you can probably write a tutorial of its own how you can analyze crash dumps. But what's important for you is the call stack. You can see basically what was happening, and last two entries are functions in your driver. So this one is the driver entry, which is where basically your code came, where your function in your driver came from. And the one that failed is this last one, which really gave me a lot of weird stuff, because what we're looking at is the security cookie function. That's the little kind of like a security wrapper, I guess, inside every function that ensures that there is no buffer overflow on the stack. Well, why would it fail? And it fails immediately, even before our driver entry even has a chance to load. Now, if you look at the actual error code and the status, we can see that there is a breakpoint has been reached. And this is basically int3, if you remember, right here. It actually gives you instruction. So there is something that clearly threw a breakpoint. And it seems like this security init cookie is the function that did this. So then, what I usually do, you do copy. And unfortunately, there is no menu. You just right-click it. Then you go into your favorite search engine and just search by it. And what comes up is this page. It basically says exactly what we were experiencing here. And what I learned, if you go in one of these answers, it actually gives you the reason why this is happening. And what I was able to do is to locate why this basically happened. So let me close WinDbg because we don't need it anymore, so we got the answer. And the reason we see that fault is because when we go into our properties, and we go into driver settings, and you can see that the target OS that we were building is 10 or higher. This is, you know, for some drivers it makes a difference, but in our case we just need to set it to Windows 7. Okay, and that should fix our bug check, our blue screen. Now, since we started this, let's make sure that we do this for all of the drivers, all of the configurations. Again, it's not Windows 10, it's Windows 7. Then we need to switch to release and do the same thing here. Again, release is the production version without any debugging output. And we need 64-bit and do the same thing. Windows 7. Okay, so let's go back to debug 64, and that should stick. Yep, Windows 7. Okay, so at this point we need to rebuild. And what I would do, I would actually try building all 4 configurations. So 64, then we do release 64. Because it's important, you know, if something doesn't build, you would have to actually investigate and see why. Okay, release 86. Let's make sure that builds. Okay, and then debug 86. Okay, super. So all of them build. Let's do one last time for 64-bit build. Okay, so now we can actually go into install x64 debug, get our driver file, copy it, and then we need to go back to our let's see, install inject all. We need to copy, and the driver seems to be the same size, so there's no difference here. And let's again load our little starter tool. We need a debug view. Again, make sure to check this. Very annoying, but you have to do it every time. Okay, well, let's see if we get a blue screen this time. Oh, sorry, we need to unregister it. And what do you know? We did not actually get the driver load message. And let's try to start something. Well, let's do Internet Explorer. And here you go. It started all right. And as you can see, it did all kinds of, DLL host and stuff run as well. So this means that it's working. Okay, now we need to stop it here, obviously. We need to make sure that it's a system start so that we can actually do the full test. Then we need to register driver. Sorry, not register. We need to do register and start. Again, started just fine. Let's make sure that we're doing fine here, and we can actually run open processes and not cause any crashes. And by the way, since we have error reporting set up, let's make sure that we don't have any crash dumps, and we don't. And one last thing, let's reboot and let's see if we can actually cause any blue screens of death here. Hopefully not. So yeah, I'm gonna let it record while the boot sequence is happening, just to show you what's going on in case we do encounter a problem. Okay, so far so good. As you can see, the system is relatively fast. It boots just right up, so there is really no visible delay. And let's see if we still have our file. Okay, 5K. And yeah, stuff is being added here. As you can see, there is stuff yeah, logon UI and LSAS and WinLogon and, you know, session manager and all that stuff is booting up. Okay, so one last thing, let's load up Process Hacker. And well, let's see, do we have our FAKE.DLL in here? And we do. As you can see, fake64. Let's see WinInit. We have it here. And let's see services. Have it here. Now for fun, you can probably go through all of them, but let me just see something that is more interesting. Let's say, well, LSAS. Obviously have here, and do we have a, let's see, Windows, what do you call it, the antivirus? Yeah, I don't know where they run it. I'm assuming it's also, you know, working that in it as well. And let's do, well, WinLogon. It's also running in there. So this basically tells us that our driver works fine on Windows 7. As you can see, we keep logging new entries in the log file. And eventually, I mean at the end, let's close this and let's unload our driver. Again, I'm going to open up our debug view and open up our loader unloader, driver loader unloader. I'm going to put it here. And as you can see, it continues logging new processes, and then we unregister driver, and it did so. And as you can tell, we generated this log, and everything seems to be working. Now, to get system back into the situation when you can actually remove the DLLs from the system, you would have to restart everything. That's the mistake I made when I started recording, because again, I did not do that, so the DLLs were still loaded into open processes. Okay, well, at this point, I kind of quickly showed you how you can use the WinDbg to analyze crash dumps. Now, obviously, there is a lot to it, but that analyze-v command is somewhat helpful. Now, the best way to analyze it would be to attach kernel debugger to the test operating system. I did record a video, full-length video, how you can install kernel debugger actually via a fast connection. So please check it, and also there is a blog post on my website about how to do that. So the best way is actually to use a kernel debugger if you do have a serious, fault in your program, and that's how you would actually do it, because sometimes analyzing crash dump is not as helpful as it may be. So at this point, guys, I would think that I am going to conclude this series, and as you can see, there were 17 videos on the subject. And unless something larger opens up or there is a big bug in this project, I will conclude it, and I will thank you for watching. And next time we will record something else. So see you.